Okay, so let's do maths paper 1. Going to look at earth geometry. So we have a question before us. The diagram below shows the positions of towns. We have A, B, and C. So this is the diagram which has been given. Then so this latitude, we have 60 degrees north. Then we have another latitude at 20 degrees south. Then we have this longitude at 95 degrees east, and another longitude at 20 degrees east. So the question is demanding us to find the time at C. The time at C, if at A the time is 0820. So we need first to know the formula and how time calculation is done. So from here, we know that if this is my F, let me put this latitude. So as we are moving from west coming toward east, you need to understand that we add time difference. Then from east coming to west, we need to subtract time difference. So if you're moving from here, coming to the point somewhere here, we need to find the difference, then we add to find the time which was here. If you're moving from here, coming to this point, you need to subtract the time difference, then we find the time from here. So time difference is calculated by T D, time difference, is equal to theta over 15 degrees. So since time is calculated in latitudes, the difference should come now in these longitudes. So what I'm saying now is that if here we have this latitude, we have A, we have C. So despite A and C being on the different position, it's like we have A here, we also have C here. So moving from A to C, we are going toward east. So we need to add the time difference. So if you're moving in latitude, the difference comes from longitude. Then you need also to understand that whenever we are dealing with time difference, the value for theta, so theta will be now, in this diagram which have been given, we have 95, which is east, minus 20 degrees, which is also east. So we do subtract when the position is on the same part. Then we do add when the positions are on the different or opposite direction. So since we have east, we need to subtract this 95 from 20. So 95 from 20, we're going to get 75 degrees. So this is our time difference, or this is the value for theta. So that is the basic part about time calculation. So now let's do our question now here. So we are saying that from here, if it is 0820 at A, then what is the time at C here? So from the same concept or from the same value, we need to understand that time difference is equal to theta over 15 degrees. I'll explain where this 15 is coming from. It is within the formula. So we have 95 degrees minus 20 degrees. So when subtract, you are getting 75 degrees as our theta. Therefore, if it is 820, you are going to say 75 now degrees over 15. So 15 into 75, we need to get something like 5 hours. So 5 hours is the time difference. So moving from A coming to C, we need now to add. So we'll say now 0820 plus 05 hours. So if you add now 08 plus 05, we know that here we're going to get 20, then 8 plus 5, we're getting 13. So the time was 13 hours at C. So this is how we answer time difference where latitude and longitude is concerned. All right, so apart from first question, then we also have another question which is saying a plane flies from A to B at a speed of 400 knots. How long does the journey take if AB is equivalent to 4,800? Now, we are looking at how long we are dealing with time. Then we have been given these 400 knots. So it's like if we can get our data, we know that speed is equivalent to 400 knots. Now remember, under Earth geometry, the units for speed are knots. So in this knot, we are having knot miles per hour. That is what knots comprises of. Then we also have distance A, B, which is in longitude at 4,800. So we also have 4,800 nautical miles, of course. So for us to find the time, we'll use this formula for speed, where we'll say now speed is equal to distance over time. Then we make t the subject of the formula. So when the equation is like this, you just interchange these two, then you maintain the top letter. So it will be time is equal to distance over speed. So distance, we have 400. So 400 nautical miles over speed. Distance, we have 4,800. Okay. So 4,800 nautical miles. Then you have the speed of 400. So nautical miles per hour. So you can cancel nautical miles, you can cancel nautical miles. You can cancel 2 zeros. We also cancel 2 zeros here. So 4 into 4, it's 1. Then 4 into 8, it will give you 2. So the time was 12 hours. So this is how we answer distance and Earth geometry, and time under Earth geometry. Now this question was so simple. There are some questions which are partly complex, so we need also to cover such type of questions so that at least by all means we can understand the entire concept of Earth geometry. We need also to understand that there's this formula which we use. Distance is equal to theta times 60. So this formula is always used when you have been given something in nautical miles, where theta is the difference in latitude. Theta is the difference in latitude. So a question also may come like this, where it will demand first to find the distance. After finding the distance, the time will be given. I guess so. The time will be given. Then you find now the speed. And apart from that, there are also questions which comes where now they will ask you to find the value maybe of this latitude or the value for this latitude. So that is the other part we're going to look at in the next lesson. So for today, we end here. It was just a sample. Someone wanted to know how these things moves. So I just have free time, when I have more free time, then I'm going to do more videos and more examples. So for now, we call it a day.